So this question wants you to compare a base unit and a derived unit, and then list the derived units that are commonly used for both density and volume. So essentially, a base unit is defined as a unit in a system of measurement that is based on an object or event in the physical world. So based on table 2.1 in your book, it lists the 7 groups or the 7 different base units. So for example, you have time, you have length, you have mass, you have temperature, amount of a substance, etc. So these are kind of what make up your building blocks. Your derived units, then, are defined by a combination of base units. So you can take these base units and essentially combine them in different ways to get what's known as your derived unit. So, for example, for derived unit, one example is density. And so density is defined as your amount of mass per unit of volume. So this is your mass over volume. So you have 2 common units. You either have grams per centimeter cubed, which is typically used for solids. So solids. Or you can use grams per milliliter, usually for liquids. Liquids. Or for gas. And so both of these, again, are density. You have mass over a certain amount of volume. And so volume is also a derived unit. And so volume is usually, your length times width times height. And so now because you have length in multiple dimensions, that's what makes volume a derived unit. So common examples of your volume, you can have 1 decimeter cubed, which is equal to 1 liter, or you can have 1 centimeter cubed, because you're in cubed and you're going down 1/10. Now because it's cubed, you're actually going down 1,000th. So 1 centimeter cubed is equal to 1 milliliter. So these are your derived units.